Okay, guys. So I hope you guys can hear me. I'm in the Wind River Canyon and our Wi-Fi is really, really patchy. So forgive me if my voice cuts in and out. You'll have to let me know in your comments um, if you can't hear me or you want me to elaborate on something that you couldn't quite hear. So my presentation is on Daphnia and their migratory behaviors and the predator avoidance. So to give you a little bit of background on the subject, Daphnia are of the phylum Arthropoda. Their subphylum is Crustacea. Their class is Brachiopoda, and their genus is Daphnia. They're very, very small. They're really hard to see without a microscope, especially when you are IDing them. Um, the species that we'll talk about in this study are Daphnia rosea and Daphnia pulex. To give you a little bit of background on their behavior and biology, Daphnia are filter feeders. So they'll eat a lot of algae and they'll eat various types of organic detritus, broken down organic material. Their food is gathered using a filtering apparatus. So they use feet-like, their feather feet-like structures that they'll use to create a water current, and they're called phylopods. And they swim using their second set of antennas, which are these really large antennas that they have, and they make a jumping motion. And because of that jumping motion, they're commonly known as water fleas, and they kind of have that look to them as well. They're found in various positions within a water column. They make regular nocturnal migrations. Um, and it's usually depending on temperature, food, and light availability. So the experiment that I am going to be talking about today is Denny and Carpenter, 1991, and they wanted to know if Daphnia vertical migrations were caused by the presence of predators. And they were testing Lampert's hypothesis that he developed in 1989, that Daphnia will migrate to avoid predators. So they're testing this hypothesis. They used a two-stage manipulation using two lakes where they could manipulate the intensities of predators. So they used two lakes, Tuesday and Paul Lake, and they conducted these experiments during the midday and at midnight on 15 different dates from 1985 to 1988. And this was mostly done during the summer because during the winter it was really hard for them to sample. Tuesday Lake, 1985, they removed all the minnows and replaced them with bass. Um, so this was in the presence of a fish that eats minnows. So there was no fish that was able to eat Daphnia. So they're in the absence of predators from 1985 to 1986. In 1987, all the fish were removed again and they were replaced with just minnows. So there was no more bass, just minnows. So there was a high density of minnows. So this was testing whether or not there was a shift in their vertical migrations in the presence of a predator. And then Paul Lake, they used as a control lake. So they just had bass in this lake with very, very low minnow densities. Yeah, and you'll be able to see this in the figures that they have. So these were the results that they came up with. And in this first series of graphs, the y-axis is the change in average depth. We have the year on the y-axis way down here, and then this is the month that they sampled in. So they were usually sampling in June, July, and August of each year, and midday and at midnight. And it looks like they sampled in May one year. So they were able to go out and sample earlier that year. And so on this first y-axis, we have the change in average depth. On the second y-axis, we have the catch per unit of effort for minnows here in the 1987 to 1988. And then we have the catch per unit of effort of bass here in the 1985 to 1986. So when there was an absence, there was definitely an absence of minnows here from 1985 to 1986. But it doesn't mean that they were fully gone. So it doesn't look like they were able to completely eradicate the minnows. But in 1987, 1988, there was no bass present, and there's a high density of minnows. So we're seeing a really big shift in their average depth change. So that's a really good indicator that these behaviors are shifting. And the rest of these, there's the Daphnia densities. So it looks like these, when the minnows were present, it looks like they have a preference for one species. Daphnia pulex looks like they've eaten all the Daphnia pulex, and we see a really big shift here. There's a lot more Daphnia rosea, which is this clear curve here. And we can see that as soon as they're introduced, we're seeing a lot more Daphnia pulex, and then we see a lot more Daphnia rosea in the later years. And then we have egg ratios, mean daphnid length, all not really important for what we're trying to figure out. And then we have the surface chlorophyll A concentrations. On Paul Lake, we see a lot of the same variables here, but since it's a control lake, we don't see a lot of variability here. It's just very natural variability among all these graphs. So in the change in average depth, it's very normal. Looks like they're doing their annual daily migration, nocturnal migrations. And then we have the planktivore catch per unit of effort. And like I said, there's no minnows, very, very few. And then the bass density is very, very high. One interesting thing that I noticed is that the daphnid densities were kind of interesting. We see a lot less Daphnia rosea in this group. We see a lot higher density of Daphnia pulex. And then again, we have the egg ratio, mean daphnid length. And there's just very natural variability here. And then the surface chlorophyll A, and it looks very similar to what we saw in the first graph. Now this is our this is our second to last graph. And this is the big indicator that these, that the Daphnia is shifting their behaviors due to predators. So here in 1986, we can see that there's still lots of Daphnia near the surface during the day when there are predators, or when there aren't predators. And then there's a lot that are near the surface during the night as well. So not a whole lot of change here. And this is for Tuesday Lake. And I'm sorry that my graph got kind of cut off here, but we can still see it. In 1987, 1988, we do see a shift. So there's very few Daphnia near the surface during the day when there's a presence of predators. And then during the night, we see a shift where they are all moving from the bottom of the lake near the surface. And that's a very good indicator of predator avoidance. And then Paul Lake, a lot of the same with the with the bass. They're all near the surface, very natural, regular nocturnal migrations, it looks like. And this all just depended on temperature and food and light. This is another graph indicating what they're doing during the day and at night. Here we can see our minnows in 1987. And these black dots here are, it's their average depth during the night. And then this is their average depth during the day. So during the day, we can see that the Daphnia are moving down in depth, and then at night they're moving up. And then we have kind of an outlier here. It looks like they were at the very bottom of the lake. And then we just see that there's less variability in Paul Lake. So to end up, figures 2 and 3 were the really key figures to finding out if Daphnia were shifting their distributions with the presence of minnows. This experiment is also a great example of top-down control. So when you remove minnows and you introduce bass, it shows that densities in Daphnia explode. And then in the presence of minnows, their densities go way down because of the predation that's present there. And then if you have bass eating minnows, then again, those densities will grow. And to conclude, after clearly modeling the shift, Denny and Carpenter found that the evidence definitely supported the predator avoidance hypothesis. And I added this figure here at the end to illustrate better what was going on in this experiment. I know the graphs were confusing and they confused me. But during the day, they're shifting down to avoid predators. And then at night, when it's dark, again, they're transparent, so it's really hard to find them. They are shifting towards the surface, so they are not being eaten as much. So thanks, guys. I look forward to your comments and questions, and I look forward to seeing you guys in class next week. I hope you guys' Thanksgiving was all great. So, yeah, have a good one.